Welcome to section 5.5, theorems about the roots of polynomial equations. We're going to focus on the rational roots theorem to solve a higher level polynomial. We need a way to crack the code on this cubic polynomial. We need to figure out a way how to factor it, and the rational roots theorem does just that. It lets us guess how to factor this, and it's basically a guess and check type situation. So here's how it goes. It's going to be a little weird. This is pretty much in every algebra book. The last number, when it's in standard form, is called p, and the number in front here, the coefficient, which is missing, it's 1, but there's nothing there. It's 1, of course, is q. We ratio p over q. To p divided by q. And this kind of makes sense because you need numbers to multiply together to make the 10. So like 2 and 5 make 10, 2, 5, 1. But there has to be some kind of numbers that make that last number there. So we have 10 over 2. So I write out all the factors of 10, plus or minus 1, plus or minus 2, plus or minus 5. And I have to consider negative numbers because, of course, like a negative times a negative is positive. And plus or minus 10. I'm going to divide that by plus or minus 1. So we ratio p over q. So 1 gets divided into all of these numbers. But when 1 divides into all those numbers, it's the numbers on the top of the fraction. In the numerator situation, they do not change values. So you're just dividing 1 into those 4 numbers, like you're distributing the division. So I make a pond of guesses here, plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. And that's the whole just dividing into there, and you get these. So these are my guesses, my pool of guesses. All right, it could be a murky pool, it could be a sunny beach pool, it could be, any kind of pool that you want it to be. Now we're ready to begin the process of guessing. So we're going to do a synthetic division, and we're hoping to divide these numbers synthetically into here, which is the same thing as just plugging them in using the remainder theorem, and looking for zeros, looking for a remainder of 0, because we're trying to find the zeros of the function, right? So here we go. Coefficients here are 1, negative 5, negative 2, and 10. So I strip the coefficients away from the polynomial, and then I start guessing. And one of these hopefully will give me a remainder of 0. I'm only going to do this twice, once wrong and then once right. So let's guess 2. So we drop, we multiply, we add, we multiply, negative 6, we add, negative 8, and no, that's not going to make a remainder of 0. So 2 doesn't create a factor. 2 is not a 0 of the function. It's because we need a remainder of 0. So I'm going to erase this. All right, and I've already done 2. So I'm going to try something else. Well, let's guess 5. A little birdie sat on my shoulder and told me, hey, try 5. Maybe it was a little field mouse. Maybe a little field mouse came by and whispered and said, hey, try 5. So here we go. 5. Drop the 1. 5 times 1 is 5. We add these together, 0. We multiply, we get 0. We add, negative 2. We multiply, negative 10. Woohoo! So I know how this factors. I know how this cubic polynomial factors because the two outside things make the inside thing, or the divisor times the quotient makes the dividend. So I'm going to write it that way. This 5 is code for x minus 5, and then this position here means x squared. This position means x, but it isn't there, and then this. So now I have the original form in standard form, and then down here I have factored form. Then we apply a little zero product proper t. Make yourself a t. X minus 5 equals 0. X squared minus 2 is equal to 0. Add the 5 over, x equals 5. Well, that's an does situation because I already had that answer as 5. That is a 0 of the function. That there is a 0 because it makes a remainder of 0. Then this one here is a quadratic. Now you could get any kind of different quadratic. This quadratic can be solved by just taking a square root. So we go plus 2, and we get x squared is equal to 2. Take the square root, take the square root. X is equal to plus or minus radical 2. So I have three solutions. So I have x cubed, which means there are three solutions to the problem. And there they are. There's x equals 5, which I found by synthetic division. X equals the square root of 2. X equals negative the square root of 2. Those are my three solutions. This is the rational. So the rational roots theorem gave us this rational solution, and the other two are irrational. All right, we're going to go on to the next example. But before that, we need some spinning. Woo! Let's spin it over the top of the answers. Oh, I can't see it. There we go. Isn't that fancy? Woo! So much fun. Okay. Now, example 2. Example 2 is going to be a P over Q situation. We're going to solve this guy. We're going to solve this. We're going to solve it. Find the rational roots and the other roots as well. And we're going to do the P over Q situation again, but this time Q is a number besides 1, so it'll be a little bit different. So I got P back here, I got Q up here, which is 2 over 7. Write out the factors of 2. Plus or minus, I got P over Q. Plus or minus 1, plus or minus 2, over, plus or minus 1, plus or minus 7. Then I'm going to ratio this. I'm going to take 1, and I'm going to take 1, and I'm going to divide it into each of these numbers. And I'll get my pool of guesses here. Here's my pool. So 1 divided into each of those would be plus or minus 1, plus or minus 2. And now I'm going to take 7. I'll get a different color here, maybe a highlighter color. I'm going to take 7 and divide it into each of those. So it's going to give me plus or minus 1/7 and plus or minus 2/7. So these are my guesses, my pool of guesses. So it could be a fancy pool, it could be a mud puddle in the backyard, whatever. It's a pond of guesses, and we're going to figure out which one of these will crack the case here, crack the safe, so we can get at the solutions. So strip away the coefficients. So we got 7. Oops, I don't want to put a comma there. 7, 13. Negative 16, and 2. All right. And then I need to take a guess. Well, you might think, oh, let's do plus or minus 1, and you could try that. And you're looking for a remainder of 0. And you could do all kinds of different things. But for time purposes, I have a little helper mouse here. See my little helper mouse? He's going to, maybe it's a she, or maybe the gender doesn't matter, I don't know, but then my little mouse here is going to help me out here, and it's going to say, hey, try 1/7. So I'm going to try 1/7. Now it's really weird to synthetically divide with a fraction, but you can do it. Same process. Drop the 7 down. 7 times a 7th. That's like dividing by 7 when you multiply by 1/7. So it would be 1. Add 14. Multiply 2, add negative 14, multiply negative 2, and 0. So I know that that's one of the roots, one of the rational roots. So x minus 1/7 is the code for this. So the 1/7 means x minus 1/7 because you switch the sign and all that business. 7x squared plus 13x minus 16. Oops, I'm doing the bottom part here. Got a little carried away. But I caught my mistake. That's the main thing. Started writing down the wrong numbers. It's these numbers here. The two outside things multiplied together make the inside thing. So it's 7x squared, 14x minus 14 equals 0. All right. Now I do zero product property. Okay, the first one is the oh duh situation, as in, oh duh, it has to be that. So it's x equals that, add the 1/7 over, x equals 1/7, not half, 1/7. So end of the day, I'm tired. So that's the one solution. Now the other two solutions are going to come from this quadratic. 7x squared plus 14x minus 14 equals 0. And you look at this, the first thing you notice is that you should notice is that each one of these is divisible by 7. So I divide all of them by 7. I have to solve the quadratic here. And I'm reducing the quadratic down so that it's easier to deal with. Factoring would be awesome, but guess what? This doesn't factor. So I'm going to do the quadratic formula. Or I could complete the square. Heck, let's complete the square. X squared plus 2x. Add the 2 over. I like completing the square on this one because when you have a 1 here and a 2 here, completing the square is awesome to do. So we're going to half the middle term's 1. 1 squared is 1. So I'm going to add 1 to one side of the equation. And I'm going to add 1 to the other side of the equation. This factors into x plus 1, and that's 3. X plus 1 quantity squared is equal to 3. Now I take the square root of each side. Boom, boom. Don't forget the plus minus. X plus 1 is equal to plus or minus square root of 3. Subtract the 1 over. X equals negative 1 plus or minus the square root of 3. And that's my other two solutions. But notice the P over Q thing, it found the one solution that's rational, and then I created this quadratic, right? Because that shows me how it factors. I created the quadratic, then I had to solve the quadratic. This quadratic I solved using the completing the square method. And this quadratic here, I went ahead and did the square root. But whatever quadratic you're given, right, you deal with it. That's why we know different ways to solve quadratics. The name of the section was Theorems, and the main theorem that we talked about today was the rational roots theorem, and that's the P over Q business. And that will help us figure out how to factor these higher level quadratics. Not quadratics, higher level cubics.